The temperature of the oceanic water is important for marine organisms including plants, the phytoplanktons, and animals, the zooplanktons. The temperature of sea water also affects the climate of the coastal lands and animals therein. After the lesson, you will be able to understand the layers of distribution of temperature, that is horizontal and vertical. The study of both surface and subsurface temperature of the sea water is significant. Standard type of thermometer is used to measure the surface temperature, while reversing thermometers and thermographs are used to measure the subsurface temperature. These thermometers record temperature up to the accuracy of plus or minus 0.02 degrees Celsius. With respect to the temperature, there are three layers in the oceans from the surface to the bottom in the tropics, and those are: the first layer represents the top layer of the warm oceanic water and is 500 meter thick with temperature ranging between 20 degree and 25 degrees Celsius. This layer is present within the tropics throughout the year, but it develops in mid-latitudes only during summer. The thermocline layer represents vertical zone of oceanic water below the first layer and is characterized by rapid rate of decrease of temperature with increasing depth. The third layer is very cold and extends up to the deep ocean floor. The polar areas have only one layer of cold water from the surface of the deep ocean floor. The main source of temperature of the ocean of water is the sun. The radiant energy transmitted from the photosphere of the sun in the form of electromagnetic short waves and received in the oceans of this is called the insolation. Besides, some energy, though insignificant, is also received from below the bottom and through the compression of seawater. The amount of insolation to be received at the sea surface depends on the angle of sun's rays, length of the day, distance of the earth from the sun, and the effects of the atmosphere. The mechanism of heating and cooling of the ocean water differs from the said mechanism on land because besides horizontal and vertical movements of water, the evaporation is most active over the oceans. The difference of maximum and minimum temperature of a day is known as daily range of temperature. The daily range of temperature of the surface water of the oceans is almost insignificant as it is around 1 degree Celsius only. On an average, the maximum and minimum temperature of the sea surface water are recorded at 2 p.m. and 5 a.m. respectively. The daily range of temperature is usually 0.3 degrees Celsius in the low latitude and 0.2 degrees Celsius to 0.3 degrees Celsius in the high latitudes. The diurnal range depends on the condition of the sky, stability and instability of the air, and stratification of seawater. The heating and cooling of the ocean water is rapid and a clear sky, and hence the diurnal range of temperature becomes a bit higher than the overcast sky and the strong air circulation. The high density of water below the surface water causes very little transfer of heat through the conduction, and hence the diurnal range of temperature becomes low. The maximum and minimum annual temperatures of the ocean water are recorded in August and February respectively. Usually, the average annual range of temperature of the ocean water is minus 12 degrees Celsius, but there is a lot of regional variation which is due to regional variation in the insolation, nature of seas, prevailing winds, location of the seas, etc. Annual range of temperature is higher in the enclosed seas than in the open sea. For instance, Baltic Sea recorded annual range of temperature of 4.4 degrees Celsius. The size of the ocean and the seas also affects annual range of temperature. For example, bigger the size, lower the annual range, and vice versa. The Atlantic Ocean records relatively higher annual range of temperature than the Pacific Ocean. The distributional pattern of the temperature of the ocean water is studied in two ways: horizontal distribution, that is temperature of the sea water, and vertical distribution from the surface water to the bottom. Since the ocean has three-dimensional shape, the depth of the oceans besides the latitudes has also taken into account in the study of the temperature distribution. The following factors affect the distribution of the temperature of the ocean water. Latitudes. The temperature in the surface water decreases from the equator towards the poles because the sun's rays become more and more slanting, and thus the amount of insolation decreases poleward accordingly. The temperature of the surface water between 40° north and 40° south is lower than the air temperature, but it becomes higher than the air temperature between 48° latitude and poles in both the hemispheres. Unequal distribution of the land and water. The temperature of the ocean water varies in the northern and southern hemispheres because of the dominance of the land in the former and water in the latter. The oceans in the northern hemisphere receive more heat due to their contact with the larger extent of the land than their counterparts in southern hemisphere, and thus the temperature of the surface water is comparatively higher in the former than the latter. The isotherms are not regular and do not follow latitudes in an hour than northern hemisphere because of the experience of both warm and cold air masses, whereas the isotherms are regular and follow latitudes in the southern hemisphere because of the dominance of water. For example, the average annual temperature of the surface water at the equator is 26.7 degrees Celsius, whereas it is 37.8 degrees Celsius in the Red Sea and 34.4 degrees Celsius in the Persian Gulf. Prevailing wind. Wind direction largely affects the distribution of the temperature of the ocean water. The winds blowing from the land towards the oceans and seas, that is, the offshore winds, drive warm surface water away from the coast, resulting into upwelling of the cold bottom water from the below. Thus, replacement of the warm water by the cold water introduces longitudinal variation in temperature. Contrary to this, the onshore winds pile up warm water near the coast and thus raise the temperature. For example, the trade winds cause low temperature in the tropics along the eastern margins of the oceans or the western coastal regions of the continents because they blow from the land towards the oceans, whereas these trade winds rise the temperature in the western margins of the oceans or the eastern coastal areas of the continents because of their onshore position. Similarly, the eastern margins of the oceans in the middle latitudes, that is the western coast of the Europe and North America, have relatively higher temperature than the western margins in the oceans because of the onshore position of the westerlies. Ocean currents. Surface temperature of the oceans are controlled by warm and cold currents. Warm currents raise the temperature of the affected areas, whereas cool currents slow down the temperature. For example, the Gulf Stream raises the temperature near the eastern coast of North America and the western coast of Europe. Kuroshio drives warm water away from the eastern coast of Asia and raises the temperature near Alaska. Labrador current, cool current, lowers down the temperature near the northeastern coast of North America. Similarly, the temperature in the eastern coast of Siberia becomes low due to the Kuril cool current. It may be mentioned that warm currents raise the temperature of the oceans more in the northern hemisphere than in the southern hemisphere, which is apparent from the fact that the 5 degrees Celsius isotherm reaches 70 degree latitude in the North Atlantic Ocean, whereas it is extended only up to 50 degree latitude in the Southern Atlantic Ocean. This is because of more dominant effects of the warm Brazil current in the Southern Atlantic Ocean. Minor factors include the submarine ridges, local weather conditions like storms, cyclones, hurricanes, fog, cloudiness, evaporation, condensation, and location and shape of the sea. Longitudinally, more extensive seas in the low latitudes have higher temperature than the latitudinally more extensive seas, as the Mediterranean Sea records higher temperature than the Gulf of California. The enclosed seas in the low latitudes record relatively higher temperature than the open seas, whereas the enclosed seas have lower temperature than the open seas in the high latitude. For example, Baltic Sea records 0 degrees Celsius and enclosed seas and open seas have 4.4 degrees Celsius. On an average, the temperature on the surface would really in the oceans be 26.7 degrees Celsius, and the temperature gradually decreases from the equator towards the poles. The rate of decrease of the temperature with increasing latitude is generally 0.5 degree Fahrenheit per latitude. The average temperatures become 22 degrees Celsius at 20 degree latitude, 14 degrees Celsius at 40 degree latitude, and 0 degrees Celsius near the poles. The oceans in the northern hemisphere record relatively higher and average temperature therein the southern hemisphere. The highest temperature is not recorded at the equator, rather it is a bit north of it. The average annual temperature of all the oceans is 17.2 degrees Celsius. The average annual temperature is for the northern and southern hemispheres are 19.4 degrees Celsius and 16.1 degrees Celsius respectively. The variation of the temperatures in the northern and southern hemispheres is because of the unequal distribution of the land and ocean water. The decrease of the temperature with increasing latitudes in the northern Atlantic Ocean is very low because of the warm ocean currents. The average temperature between 50 degree to 70 degree north latitude is recorded as 5 degrees Celsius. The decrease of the temperature with increasing latitude is more pronounced in the southern Atlantic Ocean. According to Krumel, the highest temperature of the surface water of the oceans is at 5 degree north latitude, whereas the lowest temperature is recorded between 80 degree north and the North Pole and between 75 degrees south and the South Pole. The average annual temperature of the Pacific Ocean is slightly higher than the Atlantic Ocean and the Indian Ocean. The lowest temperature of 3.3 degrees Celsius and the highest temperature of 32.2 degrees Celsius of the oceans is recorded near New Scotland and in the Western Pacific Ocean respectively. The highest temperature in the Indian Ocean, 25 degrees Celsius, is recorded in the Arabian Sea and the Bay of Bengal, but the enclosed seas of the Indian Ocean record still higher temperatures. For example, the Red Sea has 32.2 degrees Celsius and Persian Gulf at 34.4 degrees Celsius. The temperature of the surface water of the oceans is higher than the air temperature above the ocean surface, which means ocean surface gives off heat to the atmosphere. This phenomena influences the generation of oceanic circulation, mainly sea waves and ocean currents. It has been observed that the air temperature at the height of 8 meters from the sea surface between 20 degree north and 55 degree south latitudes in the Atlantic Ocean is cooler by 0.8 degrees Celsius than the sea surface. There is a lot of variation in the heat emitted from the oceans to the atmosphere during winter and summer, and this phenomenon causes differences of the air temperature over the oceans and continents, mainly during the winter season. The difference between air and the sea surface temperatures causes falls over the seas and the oceans. This happens when the warm air passes over a cold surface having a temperature below dew point of the air. Consequently, the air over the sea surface is cooled from below and sea fog occurs. Generally, sea fogs are frequently formed during spring and the early summer because air coming from over the land is warmer while the sea surface is still cold. Sea fogs are very common in the high latitudes but are generally absent in the tropics. It may be pointed out that maximum temperature in the oceans is always at the surface because it directly receives the insolation and the heat is transmitted to the lower sections of the oceans through the mechanism of conduction. In fact, solar rays very effectively penetrate up to the 20-meter depth and they seldom go beyond 20-meter depth. Consequently, the temperature decreases from the ocean surface with increasing depth, but the rate of decrease of temperature with increasing depth is not uniform everywhere. The temperature falls very rapidly after the depth of 200 meters, and thereafter the rate of decrease of temperature is slowed down. From this standpoint, the oceans are vertically divided into two zones. Photic or euphotic zones represent the upper surface up to the depth of 200 meters and receives the solar radiation. Aphotic zone extends from the 200-meter depth to the bottom and does not receive the solar rays. Though the sea temperature decreases with increase in depth, but the rate of decrease of the temperature is not uniform. Change in the sea temperature below the depth of the 2000 meters is negligible. The following trend of the decrease in temperature with increase in depth has been reported by Murray during the Challenger expedition. Diurnal and annual range of temperature cease after the depth of 5 fathoms and 100 fathoms respectively. The rate of decrease of the temperature with increase in the depth from the equator towards the poles is not uniform. Though the surface temperature of the seas decreases from equator towards the poles, but the temperature at the ocean bottoms is not uniform from the equator towards the poles, which means that the rate of decrease of temperature with increasing depth is more rapid near the equator than towards the poles. The result of German Antarctic expedition in 1911 revealed that the temperature at the depth of 100 meters at 7.3 degree north latitude equaled the surface temperature at 40 degree north latitude, and the temperature at the depth of 700 to 800 meters was the same as it was within the surface latitude of 60 degree north. The areas from where sea surface water is driven away by the offshore winds resulting into upwelling water from the below recorded low temperature at the sea surface, and thus the rate of decrease of temperature with increase in depth becomes low. Contrary to this, areas where there is piling of the sea water because of the onshore winds record relatively high temperature at the sea surface, and thus the rate of decrease of the temperature with increasing depth becomes rapid. In some areas, high temperature is recorded at greater depth, for example, in the Sargasso Sea, Red Sea, Mediterranean Sea, Sulu Sea, etc. The Mediterranean Sea records 24.4 degrees Celsius at the depth of 1829 meters, whereas the Indian Ocean has only 1.1 degrees Celsius temperature at the same depth. Such anomalous conditions are noticed in the enclosed seas of the low latitudes. The enclosed seas of the high latitudes register inversion of the temperature, that is, the temperature of the sea surface is lower than the temperature below. There is a clear-cut layered thermal structure of the ocean water. Vertically, the oceans are divided into 3 layers from the standpoint of thermal conditions of the sea water in the lower and middle latitudes as follows. The upper layer represents the top layer of the warm water mass with thickness of 500 meters with average temperature ranging between 20 degrees Celsius to 25 degrees Celsius. Lighter ocean water flows over the thickest of the oceans, extending up to the ocean bottoms. This layer is present within the tropics throughout the year, but it develops in the middle latitudes only during the summer season. The lower layer extends beyond 1000 meters depth up to the ocean bottoms. This layer is very cold and represents denser ocean water mass. The upper and lower ocean water masses are separated by a transitional zone of rapid change of temperature with increase in the depth. Zone of ocean water mass is called the thermocline, which extends between 300 meters to 1000 meters depth. Besides, there are several seasonal thermoclines between the depth of 40 meters and 100 meters. The seasonal thermoclines are formed due to heating of the water surface through solar radiation during summer season. There are also diurnal thermoclines which form in shallow water depth, usually less than 10 to 15 meters. The polar seas have only one layer of cold water mass from the ocean surface to the deep ocean floor. Today, we have learned about the temperature variation in the ocean, its range, and the horizontal and vertical distribution. Through this, we have learnt about the variation of surface water on different oceans, Pacific, Indian, Atlantic, and then when we dealt about the vertical distribution, we've learnt about the different layers, the photic zone and the aphotic zone, which are differentiated on the basis of the sun rays reaching